Hey guys, it's Doug here from Motion. I'm back with another Tech Tip Tuesday. I know a lot of you are rounding the corner in your projects and it's time to start wiring. If it's your first project or if you've done 5 of them, I hope this video is helpful. This is something that's confusing to a lot of people. Today we're talking about relays, when they should be used, how they should be wired, you know, the different types of relays and what they need to be used on and all of that. There's a lot to cover. I'll probably split this up into 2 videos. Today we're just gonna focus on your standard 4 or 5 pin relays. There's a lot of confusion there. A lot of you've never learned about it and just only see them, you know, built into components, but don't know when to use them on your project. And it can save you a lot of heartache. It can make your fuel pump, water pump, whatever it is, perform better, your fans. It'll keep you from blowing fuses, melting wires, and overall make for a better, safer build that performs better. To start with, I would just want to go ahead and clarify, a fuse is not the same thing as a relay. So you might ask yourself, what is a relay? If you're familiar with this, you can either tune out or listen. I think you'll learn some things. A fuse is basically a circuit protection. That means if it sees a huge load, it's going to blow to separate things so you don't burn your car down. So we're done with that. A relay, on the other hand, is basically a power distribution switch. It allows you to turn it on and off and take a large high current based off of a switch that is a small gauge, small current capable system. And a good example of that is, you know, when you're switching on a fuel pump. A lot of EFI systems, a lot of switch panels have a small fuel pump wire. You never want to run a aftermarket high performance fuel pump off of that small wire. That wire is made to be a trigger for a relay. And what that means is it's not made to carry a huge amperage load. It's simply made to trigger this so that the big amperage load off of this relay can then be sent to the fuel pump. And what that means is basically you have battery power coming in on a larger diameter power cable, and then in turn that larger cable carrying a bigger amperage is then going out to your fuel pump. And the advantage of that is that you can basically have a couple power distribution places. For instance, if you're building a car like this, and you can run one big cable to a central location like a battery post in the front and the back. If I'm wiring a car myself, I'm gonna have a power distribution up front and one out back. And that doesn't mean coming off the starter or the alternator. But what it is, it's a post with like a 0 or 2 gauge wire that runs directly to the battery. And now I have all of the ability to branch out from there power-wise. Obviously you can't switch off of that post, but you can feed a relay, and that's the beauty of a relay. If you're not familiar with wiring and 12 volt or any type of electricity, the longer length of a run you have, the more voltage drop you have. For instance, on a fuel pump or any electric motor, the more voltage it has within reason, the better it's going to perform. If you take your standard MagnaFuel 4303 pump and you give it like 11.4 volts, it is going to make way less power than if you had like 12.8 volts, aka a good alternator charging your system. I see a lot of people call in and they have issues, but they have like a 110 amp alternator and they're running a water pump and a dual fan setup and a fuel pump and every other thing you can imagine. And it's just basically drawing the system down. So take that and magnify it, because if you run a power cable from your battery in the front all the way to the back and it's a small 16 gauge wire or 12 gauge wire or something, that length is going to knock that voltage down even more, making the pump A, work harder, but B, perform less. For instance, a lot of 12 electronics are actually designed to hold up to 16 or 18 volts. You definitely want to check into that, but you know, a lot of fuel pumps, if you see a voltage increase to 16 volts, they usually will flow like 20 or 30% more fuel. That's why you'll see a lot of people run booster pumps. So to expand on that a little bit further, say you have a 99 Camaro. It was wired for electronic fuel pump from the factory, but you're going to drop in a dual 450 or triple 450 or something. The wire and the rating on that was built specifically for that little pump that was moving enough fuel to make maybe 400 or 500 horsepower. Now you're trying to do 1200. You need to use that wire now as a trigger for your relay. And that'll allow you to run a bigger gauge wire over to your junction for those pumps to power them with enough juice to A, not ruin the motor inside of it, and B, perform like they need to. I'll show you some components on a vehicle where you would use a relay or a set of relays. So the first one and the biggest one, I see cars almost catch fire annually when new projects come out are fans. For instance, this is a pair of the Durali fans. They flow like 3,500 CFM. They're huge, they work extremely well, and they do a great job of cooling. However, this can't be run with like a single 16 gauge wire. You need to run a relay for each fan at minimum, and that's going to allow them to spin faster and cool your car better, but B, keep it from burning up the wiring that's in there. That's a huge point of contention. I see a lot of people melt wiring and have fuses blow and trip and everything just off of fans. The next one is going to be a water pump. And obviously a lot of these depend upon which brand you're using. You know, a brushless motor is going to use a lot less juice than a brushed traditional style motor, but it's always good to have a relay for something like this, because ideally you're going to put a relay semi-close to where it's at, so you're going to have less voltage drop. Basically feed it with more power so it can flow more. All of this is not only a safety, but it's also so that you can just get more out of your components. Again, an intercooler pump in the car is a good option. And then the number one is always going to be your fuel system. This Aeromotive brushless 5 gallon a minute pump uses considerably less amperage, but it's still going to want voltage to work properly. So this one, they suggest using a 40 amp relay with it. So if you took your standard, switch panel that has like a 30 amp switched power and ran a wire all the way from that to this, A, it would be 10 amps short, and B, it's going to have voltage drop across that length of wiring from, usually you put your switch panel stuff up and underneath the dash. So if you ran that all the way to the back here, it's going to have a huge drop. And of course, it's even worse if you run that little baby ECU wire all the way back here. So to have a relay that's properly rated next to it is of key importance to A, you will ruin a fuel pump by not having enough voltage in it, because the motor is having to work harder and it's going to put a bigger strain on the motor and eventually burn it up. But B, it won't make the fuel flow that you think it's going to make. I have a lot of people call from time to time. We'll sell them a fuel system. They will say, I was on a dyno, it only made 900. You guys said it would make 1100. I'm like, it will make 1100. Check your fuel filters. They're like, they're clean. How do you have it wired? Well, I have this on it. That's not enough. The recommendation is this. They change it, all of a sudden the clouds part and everything works really well for them. So always important to look at the instructions you get with the fuel pump. For instance, like a MagnaFuel 4303 has a traditional wound brush style motor, and that one is going to need 240 amp relays, bar none, no question, has to have it. A, for durability, and B, for it to work correctly. Whereas a brushless pump is going to use 140 amp relay. Does it make it a better pump? Maybe, but it's just what it needs. So make sure whatever component you're using, look up the amperage rating, look at the wire size, compare it, and there's tons of stuff on Google. It's your friend as far as amperage and wire size and length and all that. I'll drop a chart below, but you can see if you click on this chart the voltage drop over different lengths with a different size wire. So definitely something to keep in mind. You can't just go about this stuff shooting from the hip. You might be able to, but it's not always going to work perfectly for you. Another confusion point is a lot of switch panels. For instance, this is an ARC auto rod controls. Almost all switch panels are built with either, however many circuits you have, but they have a 30 or 40 amp relay built into them. Some are solid state, some are not. But that gives people a little bit of a false sense of hope, because like I said before, you'll put this under the dash and you're like, it's already relayed. I don't need to put a relay. Well, yeah, you do. So for instance, on this, it'll have a rating of 40 amps NO, which is normally open, and 30 amps NC, normally closed. We'll get to that open and closed here in a few minutes, but right here you're at 40 amps. So if you have something that needs 40 amps and then you run a 8 or 10 foot length of wire to it, it's obviously going to have A, some voltage drop, and B, it's only 40 amps. So if you need a fuel pump that needs 240 amp relays, that's going to be an issue. If you have one wire that's triggered off your switch panel that's going to 2 fans to turn your fans on, and they each need a 40 amp relay, well, that's also an issue. A lot of electronics can be run directly off these relays, but a lot of these, the relay is just built into the board for function of the board. Don't think that you don't have to run a relay right next to the component you're running, because it can be a little bit of a false sense of safety. So the nice thing is, if you look online, there's dozens and dozens, hundreds, maybe thousands of options for relays. your standard 4 or 5 pin, which I'll cover the difference between those here in a minute, automotive relays for 12 volts. You'll see a variation from, your inexpensive black box ones that are just very standard component, all the way up to solid state. The nice thing is that if you don't have the actual size, say you need like an 80 amp relay, and it's just not a very standard thing, so unless you order it ahead of time, you might not have it, or the parts store might not have it, you can always double up the relays. So Magnafuel, for instance, on their 4303 and 4703 pumps has this double relay setup, and basically you just take all of the leads and combine them, and that's basically going to double the capacity of it. So you're going to trigger it off the same wire, you're going to ground off the same wire, all just tied together. And then obviously your 2 powers and your 2 powers to the component, you'll want to run those in tandem with each other. So it's kind of a nice option if you run into a pinch where you don't have, say, a 70 or 80 amp relay and that's what you need. You only have like a 40 or a 30, you can just double them up. So we get a lot of questions about solid state relays. Solid state relays are great. They typically trigger faster on and then release faster because there's no internal moving components. Like I said, I'll make another video on solid state relays in the future. Those are going to be more for a situation where you're controlling solenoids or trans-brake solenoid, that type of thing, where you're really concerned about how fast something's turning on and off. You might also use it on a circuit where you PWM, which is pulse width modulate. And basically pulse width modulate is giving you different voltages to basically slow or speed up a motor when it's not needed. So for instance, on a fuel pump, a traditional brush style fuel pump, you can PWM the fuel pump and that'll basically slow down the flow so that you're not overflowing the engine. Not all situations need that, and not all situations need a solid state relay, which is why they're less expensive and easier to come by. But the one thing you'll want to watch on a solid state relay is a lot of them aren't always faster to turn on and off. Definitely look at the spec sheet you're using. We found several over the years that it's kind of confusing. It'll either be a slow off or a slow on, and not all relays are created equal. You definitely, along with anything else you buy, want to buy from a reputable company. You'll see a lot of knockoff relays out there from China or whatever. The best ones are, honestly, all joking aside, made in the USA, Japan, Germany, maybe a few other places, but definitely get yourself a good one because it can also cause you problems. Okay, so now that we have explained where you would use a relay and in what situations and how they're a benefit, let's talk about how you wire them. So the nice thing about relays is they're standard. As long as it's not a solid state relay, some of those will change, but your standard 4 and 5 pin relays are all identical. And really even your 4 pin and 5 pin are the same except for the addition of this center pin, which you can see here, which is called 87A. A 4-wire relay won't have that pin, a 5-wire obviously will. The only difference between a 4 and a 5-wire is it gives you the ability to have power running to a component without turning the switch, and then when you turn the switch it turns it off. But we'll talk about that more here in a minute. The standard positions, as you look at this relay, you can actually see that all of the pins are parallel to the side they're on except for the locating pin number 30, and that is going to be your power from the battery. So that wire is going to go right to battery 12 volts or positive side of the battery, or to your power distribution lug, whether it's in the front or the back. As you can see in this harness, they actually have that one as red, nicely enough, and that wire's a bigger gauge than the rest because it's carrying all of the current. Just like you would feed a fuel pump with a bigger line than what you're putting out of it, on a relay you're going to put a bigger wire from the battery going into the relay than what's going to the component. So let's just go ahead and go through all of the pins on this. As you can see, this is an exact duplicate, and on the actual relay here you can see the numbers. And like I said, these are standard. These numbers are going to be every relay regardless of where it's made. As long as it's a 4 or 5 pin relay, this style, they're all going to be numbered, so it won't throw you, different manufacturers don't have different numbers, so it won't confuse you. So we'll start with number 30. That's our locating pin or our power from the battery. That is always going to go to your battery. Then we're going to move to 86. That's always going to go to your ground. So these two, 86 and 85, are going to be essentially what flips the switch on the actual relay. I'll actually erase this 87A here for a second and kind of show you how this works. So essentially, we're just trying to get power, a big power from here and then out of this side. But by doing this, in a standard mechanical relay like this, it looks like this inside in a mechanical relay. Basically, once this is energized and gets plus 12, it's actually going to move this little finger over to here, which obviously it'll move, and then it will complete that circuit. So now you have a bridge between your battery and what it's going out to. This is always going to be coming from your ignition switch, an auxiliary switch, like if you have a switch panel in your car. For instance, if you take that little bitty fuel pump wire that comes off of a lot of EFI systems like on a Holly, you will put that into this because it's carrying a small current, and all we're physically doing is to switch this so that we can run a bigger current to our component. Hope that makes sense. Basically, this is always going to be whatever you're wanting to trigger the relay with is going to go into 85. And then 87 is going to be what we're finally trying to power. So that can be anything like a fuel pump, water pump, fans. Could be used for coils on a coil harness, ignition coils. Some guys will wire even fuel injectors off of it so that they can pass a high current that's turned on by the ignition. The nice thing about if you do that, we're kind of getting off in the weeds here, is if you have your fuel injectors and your ignition coils powered through a relay that's triggered off of, say, a switch in a car, you're not just praying that the EFI system works correctly. If you want to kill the car, you can always just reach up and kill that button, and it's going to kill all power to ignition and fuel injectors at the same time, so the motor is dead. One of the problems with an internally circuited EFI system is it could get a backfeed from something that could keep powering those coils or injectors. You might kill one or the other or neither or both, and you just don't know for sure. But if you power them through a coil harness separately, but then just trigger them with the regular EFI, you can always kill the power that feeds them. As you can see, you're basically using these two pins to complete a circuit that moves your contactor over, and then it basically creates a bridge that allows the battery 12 volts through that big red wire to go to your fuel pump, water pump, whatever. So very simple if you really break it down. You're triggering a circuit that moves a mechanical switch that then allows power straight through the relay. And when I say power through the relay, I mean a bigger wire to carry a bigger current, to lose less voltage, over distance. And that's just basically the concept that we talked about before. The only difference on a solid state relay is that this isn't a mechanical function. It's done internally through electronics inside of the relay on a solid state. And what happens is that time for that mechanical switch, because it's not a mechanical switch, is faster. So it'll turn on and off faster. True functionality of a relay on a mechanical relay, it turns on faster than it turns off. Basically, the reason why they used to have that 87A is because before you power this, turn a switch on, this would always be powered. As soon as you switch it and it moves that contactor, it's going to turn that off. So before solid states came into play and people were worried about speed to turn something off, that's why they had something like that. So as you can see, a mechanical switch having that extra pin allows you can actually put something on each one of these, just not very commonly used this day and age because you have you have boards and you have solid states and everything. So it's kind of done away with that, but there might still be some instances in it. But for most people, you're only trying to turn a component on, a fuel pump, a fan, whatever. So a lot of times people just don't hook that 87A up anymore. If you have a 5-wire system, you don't have to do anything with that 87A. You can wire it just like a 4-wire, which is nice because depending which one you have, makes things really easy. These are all standard, so every relay that you're gonna get is gonna have those same numbers. What I would suggest, what I do, because I wire a car maybe every 3 months, 6 months, a year, I don't know. Not very often, not every day, so I kind of need a little bit of refresher real quick, question myself, whatever. I will drop a link to a diagram. What I would suggest is printing that off, tape it to the wall in your workshop, put in your toolbox. That way you can always reference it. Once you learn how to wire these, it's really simple and the benefits are huge. Hopefully it all makes sense. Just remember, number 30 is always going to be your battery plus 12, coming straight from the battery. 86 is ground. We're using these two to connect to whatever component. 87 is going to be your component. This is what your switch is going to come from, your ignition, your auxiliary switch, or your EFI system, or whatever you're using to trigger things. Again, not to be too elementary, but you can actually hook a spade connector that you can get at a hardware store right to any of these pins, but that's kind of a pain and it doesn't really secure on very well. You can also buy from a variety of different places. Even a lot of parts stores have these just pigtail style harnesses. Some of these are even weather sealed, but this one from MagnaFuel is just pre-crimped if you don't have the crimper, and it just kind of clips right in there, which is really nice. Comes pre-terminated with all the wires. Good way to wire things. The little spades tend to pull off. We sell these on our website. I will grab these for projects around the shop often. They have 40 amp relays. They also have a dual 40 amp relay. I'll put those part numbers down below as well. It's a nice, handy, inexpensive option to grab, and then you don't need any special tools to install. Okay guys, so a couple key takeaways. I hope this video is super informative for you. If it's your first time or your fifth time and you weren't doing it correctly before, I hope it kind of opened your eyes. Let's just go over a few key components behind this. First thing you want to do is understand the amperage rating that your component is using. Second thing is take that information on what your component is needing for amperage and voltage and match your relay or relays to match that. Third thing you want to do is make sure your wire size will carry the load of what your component is demanding. Obviously, the closer this is to your component, the better, but your power is coming from somewhere. So make sure your wire sizes are appropriate. Last thing I was going to mention to you guys, you can still use a fuse in line of a relay. Just make sure you aren't using it in place of a relay. I hope this all makes sense to you guys. Of course, if you have any questions or comments, concerns, or if you want to know what your fuel pump, your fans are going to need, you can always give us a holler. Call our phone number, it's in the description below, or jump on our website. We have all the instruction manuals in the product listings. We will see you guys next time. Thanks for tuning in. Don't forget to hit the subscribe button.